Let's look at another example. Let's look at problem D. In problem D, we have, let's see, 4x to the 3 halves plus 5 equals 21. So how would you solve this equation for x? First of all, we need to get the x term by itself. We'll start by getting rid of that plus 5 by subtracting 5 from both sides. What this will give us is it'll leave us with that 4x to the 3 halves equals, now the 21 minus 5 on the right hand side becomes a 16. I still need to get the x term by itself by dividing both sides by a 4. That will give me the x to the 3 halves is now equal to, well, 16 over 4 is just 4. Now, the key on this is to remember, what does that 2 on the denominator mean? It means that you have a square root. So to get rid of a square root, we're going to square both sides. So what this will do is the squaring will get rid of that square root, which will leave us with x cubed on the left-hand side. On the right-hand side, we had to square that as well, so 4 squared is 16. Now, I've got x cubed. How do I get rid of the cubed? Well, I'm going to do its opposite, which is a cube root. If I do that to one side, I'm going to have to do that to the other. What this will now do is get rid of my cubed with the cube root, which will leave me with x equals the cube root of 16. Now that answer isn't quite done. It's almost perfect. The problem with any types of roots is you have to make sure they're reduced. Meaning, is there anything hidden inside of the 16 that I can take the cube root of? There is nothing that when multiplied by itself 3 times will give you 16. So you can't actually take the cube root of 16 directly, but you can break down 16 into 2 times 8. And you can take the cube root of 8. What multiplied by itself 3 times is 8? Well, that's just the number 2. So you can take the cube root of the 8. It will come out as a 2. However, the other 2 is stuck inside the cube root because you cannot take the cube root of a 2 by itself. So our final answer here is going to be 2 cube roots of 2.